In this video, we're going to take a look at a complex fraction. There's really nothing complex about it. You can think of it as a fraction within a fraction's fraction of a fraction. Okay, maybe that is complex. However, it's nothing more than a fraction of fractions. That's all it is. So we can split this up a few different ways. I'm gonna give two major methods, and there's probably 17 million others that are out there. But here's two major methods. The first one I tend to show is, I call it the 1, 2, 3 because I try to label everything and just kind of help people through it. So what you're going to do is you're going to treat these as three separate problems. The first problem is going to be just the big numerator, the top. And so we're going to call this number 1. And then the next piece is going to be the big denominator. We'll call that number 2. And then what we're not seeing here, because now it's covered up, is that we are dividing both of these. And so that's really going to be the number 3. 3 is just number 1 divided by number 2. And what we're going to want to do is we're going to want to get each of number 1 and number 2 into a single fraction. That means that there's a single denominator and we don't have to worry about anything else. All right, so here we go. Try to keep the colors the same. So number 1. And all I'm going to do is rewrite it for right now. Minus 6 over x squared. Okay, so I've got 3 over 6 minus 6 over x squared. And then I just look for what's missing. So I look at the denominators. And when you're dealing with letters, it's a little easier than with numbers. You just look to see what's missing. So in this first denominator, we have 1x, but in the second one, we have 2. So I'm going to need another x. Well, that means because I have x squared, I'm multiplying x and x. I just need another x over here multiplying. And therefore I just throw one in the top as well. So I'm going to have an x over x here, so that's going to give me a grand total of 3x minus 6 all over x squared. That x squared becomes that common denominator, and then I just do whatever the operation tells me to do. Now, we can factor this, and if you want to factor it beforehand, you can go right ahead. But I'm just going to let it be for right now and sing the song. We'll come back to it later if we have to. All right, so moving on to number 2. We've got 1 over x minus 2 over x squared. And again, just like in the first one, we have this x squared, and we seem to be missing an x over on the left. So we're going to put an x in the bottom and an x in the top using multiplication. That's going to give me a common denominator of x squared once again, but at the new numerator, it's going to give me x minus 2. All right, so here comes the big one. Here's number 3. Number 3, I'm just going to take number 1 and divide it by number 2. But instead of using what they used, I'm going to go ahead and I'm going to use my new fractions. So my number 1 was 3x minus 6 over x squared. And then instead of using the over in the fractional format, I'm just going to put divided by as the actual division symbol. So then I'm going to also put in number 2. So it's number 1 divided by number 2. So it's x minus 2 over x squared. And the reason I used this particular notation instead of the complex fraction notation, it's easier to see what you have to do. I won't repeat what I had some students remember this as when I taught them fractions. But you have to flip it. And so we're gonna not it, just like we did in fractions of just plain old numbers. We're gonna not the division. That's gonna give us multiplication. Now the 3x minus 6 over x squared stays put, and then we're gonna not this second fraction here to make it x squared over x minus 2. Right away, you can see that we can cancel stuff out, but sticking with my 4-step process here, where I factor, and then I do the thing, and then I factor again, and then I start canceling, I'm going to go ahead and I'm going to actually factor before I do all that. So this 3x minus 6 I can factor into 3 times x minus 2. And then that's over x squared. And then I can just extend this fraction bar here and include my x squared in the top and my x minus 2, making sure I put it in parentheses because it is an entire unit on the bottom. Given that, our x squareds will cancel, our x minus 2 will cancel, and we are just simply left with 3. So apparently all of this breaks down into 3. So if you ever wanted to write 3 in a slightly different way, there you go. So, hey, it's probably good for somebody. All right. Now, the second method is a little bit different. It follows much more this idea of the least common multiple. So if I rewrite this slightly, 3 over x minus 6 over x squared, this particular method actually performs better if you leave it in complex fraction format. 2 over x squared. All right, now what I do need to find is I need to find the least common multiple of every single one of the 4 denominators. And the least common multiple of x, x squared, x, and x squared is just x squared. So my least common multiple is x squared. What I'm going to do then is, instead of trying to get common denominators and combining fractions like I did in the first method, I am going to choose to multiply the large numerator, so the 3 over x minus 6 over x squared, all of that by x squared. And I'm also going to multiply the large denominator, the 1 over x minus 2 over x squared. That's going to be multiplied by x squared as well. So you notice that I still have this x squared over x squared. It's just 1. I'm changing the look without changing the value. But when I do this, all of these x squareds are going to come into the numerators. So I'm going to end up with 3x squared over x minus 6x squared over x squared. And then in the denominator, it's going to be x squared over x minus 2x squared over x squared. And so don't forget, you're distributing this through. Now, here's the big issue. This is a little bit awkward for me to do visually. I usually talk my way through it because things start canceling out. And so I have a 3x squared over x, meaning that one of the x's in the numerator and denominator are going to cancel, leaving me with 3x. I have minus 6x squared over x squared. The x squareds will cancel, leaving me with just minus 6. Divided by. In the large denominator, I have x squared over x. That's going to cancel one of the x's, leaving me with just x. And in the second fraction, I have 2x squared over x squared. That's just simply going to cancel out the x squareds, leaving me with minus 2. So now I already have something that looks a little bit easier than I did in the first example. And I can factor out this 3x minus 6. 3x minus 6, I can factor out the 3. So that's going to give me 3x x minus 2, and I get x minus 2 in the denominators, or in the new denominator, and so those cancel out, and I'm left with just 3. Whichever method you choose is entirely up to you. If you're one of my students, I don't care how you do it, just as long as you're not cheating doing it. If you have a method different than these two and you like to use that, check with me first just to make sure it's legit and always works. Other than that, you're more than welcome to use it. I don't care. So I hope this helped, and if you find a different way of doing it, let me know. Take care.